Okay, so good afternoon, everyone, and welcome to this presentation of OTF Connects titled Using Math Moment to Multiply Math Skills with Carl Pearce and John Orr. This is the fourth episode of a series of 10. So for those of you who have not participated in the last three sessions, Kyle and John have already covered a number of subjects. The first one I wasn't in. I don't exactly know what they did during the first session, but the second session was called additive thinking. And the third one was called multiplicative thinking. And today we are going to cover fractions, decimals, and percents. I just want to do a quick message regarding native territories. OTF asked us to do that before each session, so let me read it for you. We acknowledge that we are gathered in the territories of various indigenous people, and we further recognize their stewardships of these lands in which we live, learn, work, and play. As we agreed pretty much last time, since most of you are going to come back to all these sessions, I see a lot of familiar faces already, and you're going to be coming back to all the sessions. I'm not going to read the entire bios of Carl and John, but I can recommend you to visit their websites if you want to learn more about them. Kyle has two websites. His main website is called tapintoteensmind.com, and then he has another one called Math is Visual. And I like really the use of the geometric forms for the logo. I think that all of you have really, the two of you have really great logos. And then John also will be with us for all these sessions, all these series of 10 sessions. Yes, this is session number 4. We have had 3 before. And again, John has 2 websites that I invite you to visit as well. One is called mrorisageek.com, and the other one is called mathbeforebed.com. So that's it for the introduction. We have about 40 people in the room. We're expecting probably another 20 or 30 as we go with the introduction. So I'm going to leave it to John and to Carl to launch the session. Thanks.
Awesome stuff. Thanks so much, Michelle. We always enjoy chatting with you and kind of conversing before these sessions, but also after and in between. So thanks so much for that intro. Kyle is getting the deck ready to go here. I just want to welcome everybody to our 4th session. And Kyle just threw in the chat a question on like, is this your first? Is it your second? Is your third? And we're seeing lots of folks here from 4th session in a row, 2nd session. It's awesome to see so many of you back, and also welcome anyone who it's their first session with us from OTF here on this series. So thanks so much, and we're ready to rock here. Kyle, let's get ready.
All right, I am super excited. It's great to see. I saw Ezra. I recognized Ezra's name from my session I did last night through my district. And we have so many University of Windsor friends joining us in the Greater Essex County District School Board for some professional learning after school. So it's great to see some of you coming back for more. And tonight, we're going to be, I lied. I have the wrong slide up. Tonight is fractions, decimals, and percents. Next week, we're going to have ratios and rates. So that one sort of blew up in my face, but that's okay. So definitely come back next week. We're going to keep diving even deeper into some of these ideas. But tonight, it's going to be fractions, decimals, and percents. And John, I don't know about you, but I am super excited to dive in.
Yeah, I am, as always, excited. And fractions, decimals, or percent, I think one common denominator, if I might say, is when you ask teachers, if you ask teachers, like, what is a skill or a topic that they are worried about or teaching or concerned about or trying to like help kids master is fractions. And it's like, how can we help kids the most? Because high school teachers, this, Kyle, that grade 8, 7, 8 teachers are saying, well, what should the kids know to go into high school? And high school teachers will say, well, the kids need to know their fractions, right? So there's always that.
you say it, John? I'm just curious. Is that what you usually respond?
I have to do
your
this.
family of
I have
school?
to do this. Even though we've talked many times about this idea of passing the baton down, and it never ends when you know the next grade level says you need to know these skills. But I think we as teachers definitely think, you know, fractions are a worrisome topic, and we want to make sure that we're here today to make that a little bit easier for all of you. I think they don't have to be a worrisome topic to teach or for students to know. We want to kind of dive into that, and so we're gonna kick things off pretty fast here into this session to help you with that. But so, like we start all of our sessions, we start with the what you'll get. As you stick around here with us on this session, and just like our last session, our previous sessions, that's one of the what you'll get is investigating fractions, and we're going to investigate decimals and percents. And the big push that, you know, if this is not your first session, is that we are going to push this idea of representing these conceptually. We're going to be using models. We're going to show you some of those here today. So that's always been our push. That will be our push for all 10 sessions, is how can we represent some of these skills with represent them conceptually, but with models. So that's one of the what you'll get. Cal, what else will they get by sticking around?
Yeah, as usual, we are going to continue trying to spark curiosity. Again, I like reiterating this just to make sure that sometimes how we spark curiosity with educators might look and sound a little different than with students. But today, we're actually going to get you to engage in a task pretty much straight up the way we would do this with students. And we really, as we get into more complex scenarios, like if you remember back, for those who were with us with the additive thinking situation, it's a little bit different because, you know, we're so conceptually further down that path than maybe our students. But we're entering into a land now with fractions, decimals, and percentages that some of us may have never quite grasped conceptually. Now, I'm not suggesting that you don't know how to work with them, but we're going to try to spark your curiosity and also help you build that conceptual understanding like John had mentioned. And then finally, John, what's the last thing that we're going to continue working on in each and every one of these sessions?
Right. So this slide, we copy and paste this slide from session to session, just because this we want to continue every time, which is helping you know, you repair or strengthen your relationship with mathematics. We want to promote a productive disposition towards mathematics, not just for you, but also for your students. So we want to help you become comfortable with understanding the math so that you can make your students comfortable with the mathematics you guys are going to work with.
Fantastic. So friends, you know all about our websites. We're not going to spend any time on them. They're going to be in the links just like Michelle had shared. So a couple of sites that John has, definitely check them out. A couple of sites that I've been working on for many, many years. Again, those will be included in the link. So check them out, or just Google our names and I'm sure they will come up. And then finally, the podcast, something that hopefully in the chat, any new listeners now, since you've been doing these sessions, how many folks have hit that subscribe button? Because John, I don't know about you, but I've noticed a bump up in the number of listens that we've had. We get to see some stats on our end. So pretty awesome. Let us know in the chat if you're listening in to the podcast. So where we're going to pick things up is just like usual with our 3-part framework. We're going to start by actually sparking some curiosity with you today, and we're going to dive in. This one, we're going to need to see some folks active in the chat, and hopefully we're going to get a few friends to share with us over the microphone as we do some of the work today. And I'm really excited about this one because actually this is a task that we just shared with our Academy friends. It is going live this week. Hopefully this weekend sometime, we will have an entire unit, and we're going to be essentially handpicking some pieces from that unit for this particular session. So we're going to begin, as we do many of our lessons, with a notice and wonder. So friends in the chat, I want you noticing and wondering anything and everything that comes to mind. Are you ready? If you're ready, I want to see in the chat, I want to see folks saying, ready, Let's see it in the chat. We can't. Okay, Michelle says, "Woohoo! Awesome."
Are they ready?
Tiffany's,
Yeah. And I'm wondering, Kyle, we were just chatting with some folks this week in one of our live Q&A sessions with Academy members, and they remember that technique when you're doing things live on the computer, say through Zoom or Google or your Microsoft Teams sessions, if you are going to be teaching remotely. Remember that they call it the waterfall method. So I'm wondering right now is Kyle's going to show you a clip in a moment, and we're asking you to write down anything you notice, anything you wonder in the chat box. However, I've got one kind of rule that I want to give a try here is that I want you to type in anything you notice and anything you wonder, but don't hit enter yet. And then what we'll do, right, Kyle, is after the video clip plays and we wait maybe like 30 seconds, we'll say hit enter, and then everybody's notices and wonders will just flood the group chat, and we'll see them all kind of pop in, and then everyone can scroll back up through them to see what everyone else noticed and wondered. So the nice thing about this is those aren't funneling in, and as you're watching and trying to wonder, notice, your guys are going to glance over to the side and say, okay, oh, so-and-so just noticed that, so I'm not going to say it. So we'll get lots of different noticings and wonderings. It's a benefit if you are running a session like this online, which we've done lots of when we were teaching online, but also this is also great in class because it's like a think, pair, share. Instead of you can have them, normally they share to each other and then share out loud. Now we can just say we're going to share out loud here together. What do you think, Kyle?
Oh, I tested. Ray had suggested you have to hold shift to shift the paragraph down, but
right. If you're
unfortunately for me on a Mac, that didn't work for me. So
I believe
be careful.
For us, it's command, I think.
It's like command or something. So just be cautious. Don't be that person. I know that would be me. I would hit enter, go, oh, darn, I just hit enter.
Enter doesn't bring you to a new line. Yeah.
I love this. I love this strategy. So here we go.
All right, here we go.
Everything goes.
Type it, but don't hit enter yet. Here we go, Kyle. Show us.
Right. Put those worms below the green line once they're on the string. No touching the string, no touching the worm, and absolutely no touching the race board.
What is happening?
Ladies and gentlemen, let's cheer these woolly worms on. These racers spent a lot of time and energy training these woolly worms for this race. Let's show them some appreciation. And the king in lane 17 is in an early lead. Ooh. Here comes Muzzy Jr., the king.
Is that guy just eating?
Down there in lane 7 is Flash. Flash and Woodcutter. Flash is stopped. And there goes Flash again. And here comes
All right. Are you ready?
Are we ready to hit enter?
Give them 30 more seconds. 30 more seconds.
Okay.
Some people are typing like I was watching. I wasn't typing. So give them 30 more seconds.
Yep. Let's give them 30 more seconds. Try to hold back from the enter key if you can. Hold back if you can. Right. And then John will do a countdown.
All right.
To reveal.
All right. Ready? Let's on the count of I'll count down from 5, 4, 3, 2, 1. Hit enter. Whoa.
Look at that.
All right, there they are.
Holy smokes. Now, right, John, the thing you didn't think through was how you're going to try to help
I'm going to scroll back to the top. That's what everyone's doing right now, right? Because it's the nice thing, too, about you've typed it. Now you can go look. Because sometimes you're typing and you can't look while that's all happening. So I am going to scroll back to the top. I'm going to read a few out loud. We got notice caterpillars on a line. Wonder what is the prize? It's a caterpillar race? ? I wonder if they're having a race.
What the heck?
People are of different ages and contested some sort of competition. How long is the string? A worm race, a woolly worms. The worms have names. Caterpillar race. I'm scrolling now. Is it at a fair? What game is it? What color? Not sure what we're racing, but they mention worms. Notice people are playing a game. There's social gatherings. I'm going to throw in one more. Remember the one we had the other day, which was like, clearly this was pre-COVID. So
exactly.
wonder what is the game. All right, awesome stuff. Lots of noticing and wonderings in there, Kyle. I think the waterfall method here worked pretty good.
It sure did. I love that suggestion because we didn't pre-plan that, but that's definitely one we're going to have to put into use in the regular repertoire. I just want to share, this is part of the slide from this morning. I went into a classroom. Again, students didn't know me very well. I'd been in the class a few times before, came up with some similar noticing and wondering. I didn't write them all down here, but this was just another way that I, on the fly, was typing this in. I had the actual classroom teacher read them out just like John did. And I tried to put them in because, again, I wanted like Alexander and Spencer and Malia and Francesco and
Kyle,
some of the students that were sharing.
Were you doing this through like digitally, or were you actually in the classroom?
No, it was a digital classroom. Yeah, I should have referenced that. So it was just like this. There were many more things shared out, but I just wanted, again, just to give them that little extra sort of like showing that I truly care about all of these noticing and these wondering. So the students, I think, appreciate that as we build that trust. So you got to spend that time, as we've said before. So a few things that I want to like kind of address here. So first off, some of these noticings and wonderings, like I can help you out. Like some people are saying, is it a caterpillar race? And I'm going to tell you right now that actually, yes, it is a caterpillar race. Some people were saying like, how long is the string? I'm going to actually tell you how long the string is, but just in a moment. I'll let you know in a moment. Some people were saying like, what's the woolly worm race about? And actually, I've learned through this that like woolly worm is like an actual type of caterpillar. So I thought that was kind of interesting. So
I just learned
very interesting noticings and wonderings going on here. Now, some people in the chat, like Ali was saying, like, what are the rules of this game? And I'm so happy you asked because I want to show you the rules of the game. First off, they all begin at the start. And someone asked about how long the string is. The string is 2 meters long. Now, here's the deal. It's 2 meters long. Now, if in a perfect world, these caterpillars will all make it to the end of this race, but I don't know about you, it's hard to coax a caterpillar. Some students actually today, they said, you know, there was like people rubbing their hands. Like, is that like the sound make them go? Like, I have no idea, but these are all really interesting wonders. But what I will say is that right on the screen, right here, this is the winning woolly worm. All right. And what we did is we sent these worms up, and it's really after a matter of time, we sort of say, okay, the race is over. After that timer goes, we then measure to see who went the furthest. And I want to show you here, when we started this race, this particular woolly worm was the winner. And this is to scale. The woolly worm made it to, oh, not to there, but actually right to here. And this is where that particular woolly worm landed. Okay. Now, my question to you folks, and we're going to hold back too, we're going to try this waterfall method again. My question coming up to you is going to be, how far did the winning caterpillar travel? We don't know which one it was. We don't know if it was Yo Gabba Gabba, like you saw on the sign, or if it was Abby, or any of the other woolly worms that were out there. But we want you to make an estimate. But before you do, we're going to first use some of those rules that we've set in the past, which is we're going to try to like rule out some estimates. Okay, so we're going to try to be to set ourselves a bit of a range. So we're going to, first off, I'm going to challenge you to share. Don't share yet, but we're going to, on the count of 3, we're going to have you share what would be a distance that you feel is too low for this distance. Now I'm going to, again, reference, we're starting at 0 all the way to 2. What are some numbers that you think are too low? And I'm going to even argue right now, since you've done this with us a few times, be risky. Like, see if you can be risky with some of those. All right. So John, I'm gonna put it to you to get this waterfall started.
Right. So
we're gonna go be risky.
Yeah, so don't throw in anything yet. So we're going to go too low, and we're going to try to be risky. We're going to go too high and try to be risky. And then a third number we're going to be is your best guess. That's what you just said, right, Kyle? Just to confirm, you or did you want 2 lows just all at once?
I was going with just 2 lows first.
Okay, let's just do 2 lows.
We're going to go. Yeah.
All right,
some two lows. I see
all right,
some are
here we
already
go.
in
Two
here.
lows are coming
Give 'em
on
a
the count of
countdown
3.
for
1,
everybody else.
2, 3, 2 lows. All right, so here they come. Ooh, we've got like, I really like this, Cal. We've got 2 low of like 0.1 meters, but then we have another 2 low that's 150 centimeters. We've got 1.5 meters. We've got 1 centimeter is too low, and I like that. It's like 1 centimeter, Holly. Like 1 centimeter is too low. It's like when a student's like 0 is too low, it's like, yes, how risky can we be? So it definitely you have hit the nail on the head as a too low. Let's see how risky we can be. I would encourage that student to then be a little bit riskier with your too low. Like, we know 0 is not right, but I wonder if we can get a little bit more risky. We've got some 1.75s, a lot of 125 centimeters, a lot of 1.5s, lots of 1.5s actually. We've got 1.7, looks 1.75, Kyle, looks to be the highest too low. I always like to pull out the highest too low and the lowest too high, but the highest too low I have is about a 1.75, which some people are like, that's a little risky. So we've got that right there. Let's get some too high. So the nice thing is too, is we're putting out wrong answers. And we've done this, I think, every session we've had so far, because we use this technique a lot in our classrooms to kick off, say, the topic or the unit, and on when we do a problem like this. But let's do too highs, but let's do the waterfall method. Don't throw them in there just yet. Give me a too high. I think we know 2 is too high because the max can be 2, but give me a risk factor on your too high. On the count of 3.
Yeah, like the hill says 700 kilometers.
Yeah.
Definitely too high. Definitely too high.
1, 2, 3. Hit them in there. Give me some too highs. Here we go. I'm seeing 1.9999 meters, 1.9, a lot of 1.9s, a lot of 1.95s, Kyle. People are like, it's pretty close, but I don't want to be too risky, right? So we're saying, like, I think everyone's like, I can't say 2, but I'll say 1.9, and which is pretty good. I think that's a pretty good too high. I don't know if I'd be riskier than that myself.
And now too, I also want to mention too, because something that in the facilitator guides, like I've been kind of working with one of our writers on this, and we're going to get really particular about the language that we use in this lesson. So a lot of students this morning, for example, said 1.9. A lot of students said 1.95 or 2. And what I'm going to encourage us to do for the rest of this lesson is I'm going to get us to start using the actual decimal representation according to their fractional values. So for example, I'm going to encourage this language of like 1 9/10. And I'm going to encourage like 1 95/100. And we're not going to correct students, or we're not going to tell them not to use the language you're using. But later in this lesson, you're going to see that there's going to be a reason why this language might be helpful for our students. So we're going to keep on pushing that. And John, I think we are ready for like our best guess here. So I'm going to encourage folks to get themselves ready. And then when John says, make that thing, we'll say rain, but it's waterfall, right? So we'll make it waterfall when John says, with your best guess. And this is the one I really am going to be caring about here.
All right, so in a moment, we'll do a count to 5. You're going to type in and hit enter on the count of 5 for your best guess. 1, 2, 3, 4, 5. Give it to us. Give us your best guess.
1 85/100, I see.
We've got key says 1 8/10. I'm seeing, like, and I think this is great too, Kyle, because when you say this as a teacher out loud, so if a kid said 1.8 to you and you're like, yes, 1.8, instead of saying 1.8 out loud, you could say, yes, 1 8/10. Like, you could just say it yourself and then write it on the board. And then when the next kid says 1.75, you can say like 1 75/100. No problem. I'll write that one up. And so you're actually translating for them, and then they're going to, through like you saying those languages, using that language, it's going to rub off, and it's going to kind of set the stage for what's to come.
Absolutely. And there's so much research around that in terms of language. Like students don't just pick it up like this. Like I remember I used to give definitions, and it was like all of a sudden with the definition, then I would expect students to know it and be able to use it. But a lot of it's them hearing us use it, and then they over time adopt that language.
Exactly.
So I love these guesses. Like look at how tight of a range we have. We have one that I'm interested in, this 1 in 2500ths. I'm wondering if maybe there was I wouldn't say this with our students, but maybe there was a typo, or maybe this came out of the too low area. But again, it would be like, I wonder if throughout this lesson, if they're going to want to update that that estimate. So lots of estimates. And I want to be really clear here. When we do this, typically decimal responses come back. So being the keen teachers that we are, my friends, I'm going to be giving you a little bit to work with here. And I'm going to tell you that, you know what? I want you friends to help us figure out who won this race. And actually, I'm going to have you try to help us order who came in first, second, and third.
There wasn't
place.
just that worm, right, Kyle? There was a number of worms that were in that race.
Yeah. And actually, you know what? The officials, they actually measured this out. But unfortunately for you friends, they measured it out in a slightly different manner. They used fractions of a meter here. And these are the top 7 finishers, but they're not in the correct order. So like Silly Willy didn't necessarily win, and the King didn't necessarily come in last. They are just measured and put in this table. And the question we have for you friends to engage in, and we're going to give you some time to do this. We're also going to encourage you to upload your representations to us.
We'll give that a try again.
Yeah, I think it works. I double checked the next day. It was back working and everything's good. So we will do our best there. But what we want you to do, and I want to be very clear here, because with the students, I this morning I said a few things to them, and it was in a digital environment, as I mentioned. One thing we said to them was, first of all, no robbing other students of their thinking. And I articulated what I meant by that. What I meant was that I don't want anyone in the chat putting anything about solutions right now, similar to the waterfall method. We're going to hold back, okay? We're going to hold back on that. The second thing is, we don't want you to be robbed of your thinking. And what we tend to do is we tend to reach for a calculator, but that would rob you of your thinking. So we want to make sure that you have the opportunity to represent the distance traveled by these caterpillars. And right now, tonight, even though this question, and with my students, I would encourage them to order all 7. Tonight, I want you to do your best to order the top 3. And my wonder is, when you order the top 3, is there any thinking that you can use in order to eliminate some that you are like, you know what, I'm not even going to worry about this caterpillar because something about it tells me that it's not going to be in the top 3. All right, so we're going to have you order the first 3 winners, the ones that went the furthest distance, and then we're going to be sharing that thinking out to us over the Snapshots tool, which we'll do momentarily. I'll put that up on the screen in just a few minutes. If you could, let me know in the chat, my friends. Is everybody clear, good to go? Thumbs up, emoji central. Is everybody good to go with what they're going to do?
Thumbs up. Michelle says thumbs up. All right. Yes.
Super cool.
All right.
I'm going to leave this up on the screen. And at the same time, I'm going to be adding a code for how you can upload a photo or a screenshot of your thinking. When you're ready, no rush on that. Try to pick your top 3 here, and then how could you prove to us that they are first, second, and third? How do you know? How are you going to model that for us?
All right, so Kyle's going to get that code in just a moment. I put in the chat the same link. This is the same link we used last week and the week before to upload. You need an extra device here, so a phone or an iPad or something that can take a picture. I put the link in. You can click that link if you're, say, on a device that can take a picture. Otherwise, type that in and then SIP2234, right, Kyle? SIP2234. Is the code
2234.
You can go through, you're going to log in as a guest There's like a spot you can just hit guest. You don't have to like log in or make an account or anything. You just have to put your name in, and then like Kyle says, we're going to take a picture of you're going to take a picture of your thinking and upload that, and then we'll look at all those in a few moments.
Awesome. We're going to turn our cameras off and our mics off to give you some true think time. We really, really encourage you, if you're going to spend the time with us today, spend the time, do this work. It's so, so helpful for your own conceptual understanding. And we can't wait to see what you all come up with.
I don't know, Kyle, if you want to put that, there we go, back up on the screen. That'd be great. Awesome.
All right, the first of our representations are coming in. Awesome to see those. No rush. If you aren't ready to share, feel free to share when you're ready. This will remain open even if we start to consolidate before you are finished. John, we are getting some pretty awesome representations over here. Super exciting.
Kyle can see everybody's solutions popping in on his teacher computer. So if you were just joining us, and you or actually we didn't use it last week. So if you didn't see this last week, or this is your first time using this software, knowledgehook.com snapshots, then Kyle's got a screen on his end. He'll show you in a minute. He just doesn't want to like influence anything just yet, but he's seeing all the solutions kind of pop in. People are taking pictures of their work and it's showing up on his computer. And this is a great thing to do in class too, because now those things can show up on the projector in the middle of the classroom to highlight, but also digitally like we are now. It's a way for you to grab student thinking instead of just text, right? So it's a nice way to send a picture to the teacher through this software. So it looks like you are going to share a couple.
Yeah, and you know what? I'm looking at this and something that's really important, and we're not going to get into too much during this series, but we're going to notice and name it as it happens throughout these 10 workshops. But one thing that I just did right now is for you as educators who are in a learning position, I pulled this particular representation because this representation will work. I'm seeing a lot of abstract representation going on here. I'm seeing this person is clearly has some knowledge and understanding of fractions, but what I'm hoping we can highlight here today is that, as you likely know, a lot of our students, especially students in those middle grades kind of heading and even going into high school, aren't in a position where they're ready to play with math abstractly like this. So it's like, what are we going to do to try to make this a little bit more visual? Now, something we often see here, and you'll notice that I have the names all hidden. That's another thing we love about this tool, because again, when we're highlighting, it's great if a person wants to celebrate their solution, it's great. But here, this person, something I find really interesting, and it speaks to how we learned math, and in particular fractions, that in a very non-linear or a very non-circular context, that this particular person went to pies or pizzas because many of us, that was like the only model we experienced when we were younger. Sure. Absolutely. And what this overemphasis of circular models is actually something that a lot of research is telling us that, you know what, first of all, they're really hard to partition. And if anybody wants to try that for themselves, like try to split a pie into 5. That's really hard, or 7, right? Any of those odd numbers becomes incredibly difficult with pizzas. So not to say that we can't use that model, we just don't want to only rely on that model. But this particular person, it looks like they have a really good handle on the area model using circles. Fantastic. I noticed that there's a lot of symbolic representation as well, which is awesome. Now, I want to go ahead and pull up a couple of these that were a little bit more linear in nature, but also maybe low enough floor for students to be able to access. So I see some linear right here. Here's a linear representation. I'm going to have to flip it a couple times, which hopefully the internet will make that work rather quickly. Doesn't look like it is doing that very quickly for me. Now it's fully upside down. But you can see here that this particular person is actually partitioning a number line. And that is a really great representation. And this is a representation that we want students to develop and build their fluency with. However, before we do that, we actually want to play a little bit longer in area. And the reason why is because a line is actually very abstract for students. So if you've ever had students who struggle with measurement, oftentimes it's because they're measuring something that's like flat and non-existent when they live in a 3D world. So you'll notice that like kids, when they're young, it actually makes more sense for them to measure things like volume because it's 3-dimensional, and then measure things like area, like using square tiles to cover something. And then last but not least, thinking of things linearly. So we're going to back things up just slightly, and we're going to go to a bit of area, but still keep some of this linearity involved. And because our context is about a race, that's what we're going to try to do. I'm going to try to model the context a little bit. And I'm wondering, John, if you can manage the chat, I'm wondering if you can ask someone to raise their hand, someone who's brave enough to turn their microphone on, and try to help me. I'm seeing a lot of the same names. Like I saw the King, I think, was one that people were saying. I think some people said Abby was one of the top. And then what was another one that came up I saw on a lot of people's pages? I think I saw,
Scratchy.
Was it Scratchy?
Scratchy. I was reading Michelle just typed in Scratchy. Also the Hill typed in Scratchy. Joanne saying Scratchy. Yeah, so if
Fantastic. So those are the top 3. And I think King went 1 meter and 5/6 of a meter. Abby went 1 and was it 4/6 of a meter? And finally, Scratchy went 1 meter and 1/3 of a meter. And my question to this brave soul is going to be, how can you prove to me, or how can you articulate, how can you convince me who's first, who's second, and who's third in
think Scratchy
out of
was
these
1
three
and
here.
2/3. 1 and 2/3, Kyle.
1 and 2/3. There we go.
You wrote
Perfect.
that. You did write that. Okay. So in the chat, I think the way we did this last time is you can raise your hand in the, I think at the bottom, you're going to do a raise your hand, which is, or you can do, I think a reaction, right, Cal? I think we could have like a thumbs up reaction, but I think maybe that's only on
Anything that's
video.
going to indicate to us a brave soul.
Yeah.
If I look at our participant list, I don't see any hands up yet, but in the participant list is where you can see the raise hand function.
You know what? I'm not even, maybe it's just because I'm the co-host. I'm not seeing a raise hand, but
maybe not. Yeah, I'm not seeing it either.
Oh, there's some hands. Here they come. Claudia's got her hand up. All right, Claudia, could you can you turn your mic on and share with us some thinking behind these top three, and then Kyle, I think, is going to record what you write, say, on the model.
So do you want me to start with like just one of them? And
sure.
Yeah,
okay.
like help me understand, like, what would that look like? Let's assume that these are, this is one of the lanes. It doesn't matter whose, but you tell me, which one do you want to start with?
Okay, I'll start with king then.
Okay.
So when I see that, like the line, I guess the two rectangles, each of them will represent 1 meter. So the very first one for king, the bottom rectangle will be filled out because that's 1 meter representing.
Love it.
And then I will take the other one and I will try to divide it into 6 parts.
Awesome. And how would you do this? Like, if you had to be the one to do this, like, where would you do your first partition?
I might split it in half.
Okay.
Cool.
And then I will try to divide it into 3 parts.
Super cool. So now it's like, I took this whole, I've split it in half, and then you've basically, now you're like, I'm going to split each half into thirds.
Right.
That's something really interesting about that I want to be clear about, because today in class, it was pretty cool. A student used a similar strategy. They're like, okay, I'm going to half it, and then I'm going to third that. And when a student does that, I want you to recognize the fact that you actually just took a third of a half, which is a sixth. So they're multiplying fractions concretely or visually in this case without necessarily realizing it. Mm-hmm. How crazy is that? It's like they're using this conceptual logic in order to do this. So when a student partitions in half and then thirds each half, that is actually like right there on a plate for us. But I, for many years, would have never noticed that. So hopefully that's something that maybe we can take away. How many of these are you going to fill in there, Claudia?
5 of them.
Of these sixth. Awesome. So pretty good stuff here. Fantastic. How about Abby? Like, what would you do with Abby here? What do you think?
I think I will start doing the same thing, color in the bottom rectangle, because that represents 1 meter in my head. I might do the same and just separate it into the other rectangle, divide it into 6 parts, and just color in the 4.
Super.
Yeah, the other nice thing, Kyle, to bring up is when you said, there's multiplying happening when they partitioned the half into thirds each to get 6, and then when you asked Claudia to say how many you just shaded in, and she said, I want 5 of them. That's another multiplication, right? You just did a whole number, 5 groups of 1/6. So we just multiplied 5 times a 6 right there, or 5 groups of a 6, or added a 6 5 times, right?
So, fantastic. That's exactly it. And I'm wondering, Claudia, help us out here with Scratchy. What are you going to do with Scratchy here in order for us to kind of make a determination on who won and who came in second, who came in third?
So when I was solving this, I actually took Scratchy and I looked at the fraction 2/3. I'm like, well, it's the same as 4/6. So if I were to color it in, I'll do it the same as
Sorry, go ahead. Yeah, keep going. Awesome. So you colored in a whole 1, and then you said you knew it was the same as 4/6. I'm wondering, how did you know that though? Like, how could you convince someone who isn't sure of that? It sounds like you are, and I believe you, but I wonder, how would I convince someone?
So I was actually the one who did the pie graph. So when I looked at it,
okay. Well, look at you. You get all the attention tonight, don't you? I love it.
So I did that, and like if I looked at my pie graph, like I did it in thirds, like I split into thirds, and then if I compare it, like if I add, I don't know how to explain this, but and I realized I made a mistake. Number 3 is not Silly Willy. So I kind of just I looked at the 2 pie graphs. If I cut more of, like divide the pieces, I guess, like into more parts, make Scratchy the second one into like 6 parts, it would be 4 colored. I don't know if that makes sense. I'm sorry.
No, that makes a ton of sense to me. And like, can I try to model? You can tell me whether this isn't what you're saying. It happens all the time where I think I hear what you're saying, and what I feel like you're saying. It's almost like if I look at this pie that's on your screen, I'm guessing that this one, either you split it into 6 right away because you knew you had 4 6 that you need to color, or vice versa. The other one, you did thirds and you just saw that it was like the same amount. It was like you got to compare. You didn't even have to like partition this one into 6. Is that true, or am I off on that?
So I did Scratchy first, and I did into thirds. And then when I went to Abby, I split that into, like I did a third, and then I split each piece in half to make my 6.
Super cool. Super cool. So that's very common as well. Like students that kind of have like easy partitioning, like you might resort to that first, right? You're like, thirds is easier to me than 6, so I'm going to start there. A lot of students might do that. And if I color that in, it's really plain to see that, oh my gosh, like when I actually line these up, holy smokes, look at that. I've got equivalence
Kyle,
going on. Had this.
You might want to jump back to your iPad screen.
Oh, shoot. There we are. My apologies. So this equivalence here is really apparent. And even though this lesson was not really about equivalence necessarily, it draws it out and it gives us this opportunity for comparison. You can imagine that for students, having them do all 7 is a good idea so that they get more they get more repetition with this idea of
purposeful practice in there.
Absolutely. And something that was really interesting to me this morning is that I saw a student, when they did Abby's, it was a student that was doing this one here. And the student said, I ignored the 1 and 4 6. They were like, I don't even care about that because everybody that matters went at least a meter. So he just ignored that completely. And then this student said, you know, he's like, I looked at this and all I did was I just figured that, you know, if I half my 4 and I half my 6, I end up with 2 thirds. And when you think about that, when that student does that, what that student's actually doing is it's saying, listen, I'm going to take these like 4 pieces right here, and I'm going to make those pieces into half the number of pieces. But look at what happens when I make 4 pieces into 2 pieces. What happens to the size of each piece? I'm looking in the chat here. Can anybody tell me, like,
what happens to the size? They get bigger.
The size gets bigger. Holy smokes. If you've ever done a number talk in your life where they do this thing called doubling and halving, like it's happening all the time in fractional thinking. It's like a lot of kids would say, like, this fraction, I reduced the fraction from 4 6 to 2 thirds. But I want to make you aware, you are not reducing the fraction. You might be simplifying the fraction. You might be making it, but what you're really doing is you're reducing the number of pieces and making those pieces larger. So the pieces are getting bigger and the number of pieces are getting smaller. So we are not actually reducing the fraction. It's actually the exact same fraction, that there's an equivalence here, and I'm just manipulating those pieces. So there's so much rich discussion that can be had through this. And then When we're all done, and when we're done consolidating, you'll notice here, I didn't consolidate all 7 of these. I consolidated 3. You might choose that, hey, I want to have, you know, these particular, these 3 racers, and I want to get them consolidated. For you folks, I said, let's do the top 3. I think we're all pretty comfortable that the king is the winner. And what I would actually do from this point is I would actually share with students the actual race to see how it actually played out. And you can actually see this on your screen, I hope, that if we line up all 7 racers, let's see if the king comes in first. And actually, Abby and Scratchy look like they've tied for second. Let's get them going here. Here's the lanes. Here's our caterpillars. John, go ahead and get them started.
Ready?
With your on your mark.
On your mark. Get set.
Yep.
Go.
Okay, here we are. Here we are off to the races. Look at the kings actually slugging behind. I'm not sure if you folks were correct with your representations.
Oh,
look at that.
up there.
Right at the end. Check this out. You can see that the winner for this particular race is definitely the king. Abby and Scratchy came in second. But then the big question that I would have back for my students is, who the heck came up with the closest estimate? I'm wondering who came up with the closest estimate. And if I go all the way back, the closest estimate, this is what you folks all said on your best guesses. That's what you said on your best guesses. But my problem is that I have no idea who's closest. So I'm going to give you just a little bit of time here. Go ahead. How are you going to convince me who was closest out of all of these friends? No calculators. What's your thinking? We're going to give you a couple minutes to think this through.
And Kyle, Tiffany is asking how you did the animation. So that has nothing to do with the math exercise, but maybe you will give us your secrets.
Sure,
we can. We will never share our secrets.
Exactly.
This is a common question with the slides. Is right now we're in Apple Keynote, which is Apple's slideshow software, which is like, it's like PowerPoint. So we find it a little bit more powerful than PowerPoint. And it's actually, Kyle would agree with this because we've chatted about this before, is that this slideshow software that we use, Keynote, is probably one of the only reasons we continue to buy a Mac, laptop to use as our own computers. And so, so what's happening is it looks like animation, but it's actually like, if you imagine when you were a kid, you made those flip books, right? That's animation. It's like you draw a little stick man, the stick man would move and you'd flip and it would look like you had animation. That's what's happening right here. Kyle's got, if you can check the slides out on the side, he's got many slides on the side there. Each one has
copy and paste.
Yeah,
copy and paste and move it a little. Copy and paste and move it a little.
And actually, he doesn't have to move it a little at all. He just moves it exactly. The next slide beside it, right, Kyle, would be exactly where you want that place to go. And the nice thing about Keynote is it has a transition. So, like a slide transition where you would have it fade from one slide, or it might rotate slide transitions like for an effect. Well, Apple Keynote has a slide transition between two slides that says, hey, these slides are almost the same, except that this one has a shape. They have the same shape, but on this slide, it's up here, and over here on this slide, it's down here. And so Apple will just fill in the details. They actually fill in the flip book between those two slides. So it makes it look like it's slid from here to here. It actually didn't. It's just moved by animation, because Apple kind of filled in the details between two slides. So that's it. That effect alone is really great when you're creating slides, because it makes it look like you made some sort of fancy animation, or you you had an animator make all this for us, so now it's just a couple slides put together. So that's pretty cool. You can that's called Magic Move, is the actual transition that makes all that possible. So super easy to do. We have not heard of or seen a similar effect on PowerPoint. So that's it's pretty neat. So there you go.
Yeah, super cool. It's definitely possible to do on PowerPoint, but the problem with PowerPoint is just a lot more clicks needed and a lot more work needed.
You probably need to actually move it slowly. Make one, move it, instead of just move it exactly where you want. And then Apple will figure out how to move it, how to animate it. All right, Kyle, where are we here?
Best guesses here. I'm putting our best guesses down just right here, just to make sure. And I'm wondering, friends, should we do a waterfall to like see like which best guess? What are people thinking? And then we're going to need a brave hand raise to try to get some logic on like, how would you reason through this? And this is a real good learning opportunity.
Yeah,
and this is where we kind of connect our fractions to decimals, because keep in mind, decimals are just fractions. We'll talk a little more about that momentarily.
Yeah, and just before we do that, this is also like a very important moment, I think, too. It's like you might shy away from this in your class because you're thinking, okay, I just did this activity. We ordered all these fractions. Now we're going to go back and we're going to compare, but everybody compared in decimals. And then I'm like, okay, wait a minute, but I haven't done my decimals lesson yet. Or like, it might be easy to just say, I'm going to skip that comparison when you're extending the context. Like the context is still fresh in all of our minds. And this is a great thing to kind of like, all of a sudden, we're going to now work on this one idea. It's like you're getting two problems in one. And I think it's easy to dismiss it and put it to the side, say, we'll do that later, or we'll kind of tackle that problem or that topic at a different time. I would say you're doing what Kyle's here set up is don't skip that. Don't skip that. Use it now.
Yeah, for sure. And you'll notice as well, like for anyone from our sessions, we pointed you back to some of our units on our website. So we'll talk a little more about that at the end. But all of the units that we create, we're like intentionally trying to connect to other ideas, because what do we always talk about? We always talk about how students don't remember what we did 2 weeks ago, 3 months ago, last year. We need to be bringing these things up, bringing them up whenever we possibly can. Now we need to make it engaging. So that's the other piece though, is it's like we have to make it kind of worthwhile. And right now it's sort of like, we did all this estimating at the beginning. All of you folks came up with great estimates. It was like you were like putty in my hand. You know, I was like, I know you're going to use decimals. I'm going to give you fractions. I'm going to create a headache for you so that you're like, man, now I got to actually like do something. And now I'm asking you to kind of put them together. And keep in mind, we are not pre-teaching kids this stuff. If students have nowhere to begin, first of all, the part that I first want to ask myself, if let's say a student has no idea what a decimal looks like, the question I ask is, why are we using them? And I think I know the answer to that question. I think John would agree that students at a very young age are given a calculator. And when they do any sort of division that has a remainder, what do they get? They get a decimal. So they start saying things, and we're even in habits. Like John, you said it earlier, I'm in a really bad habit of it as well, of saying 1.25. I say those things, like that's just what I'm accustomed to doing. And right now I try to make this like really intentional process of asking and using the right language so that students realize that, wait a second, a decimal is just a fraction. And in particular, a decimal is a fraction with a limited number of denominators. So if you pause for a second and think about that, you're like, whoa, what are you talking about? But the reality is that I can only write decimal numbers as a tenth, as a hundredth, as a thousandth, a 10,000th, and obviously the numbers go on. Our base 10 system limits us to this very restrictive fractional notation. And that's why we have so many repeating decimals, right? We have so many non-terminating decimals out there, is because it's not a really great decimal system. So my wonder to you, friends, is what actual estimate was closest here I want to see it. John, do you want to go ahead and do this waterfall? Let's see what people are saying.
Yeah, we're looking for a hand to come up, and or you want to do the waterfall? I thought we were going to. Okay, yeah. So let's do the waterfall first, and then we'll choose a hand.
Exactly. Yeah. So if you're willing to speak to this, like, how do you know without a calculator?
Right.
Like, what are you thinking? What are you drawing? I'll try my best to draw it out. But I see a lot of people are saying like 1 85/100ths is the closest. Lindsay says 1 833 thousandths. Do you see?
Yeah. If you're waiting for the waterfall, hit enter now.
Write that out.
Yep.
Judith is saying 1 85/100ths. Super cool. And Ezra says whoever's closest to 1 83/100ths. Holy smokes. Now here's the hard part, friends. And I'm really, really hoping you're willing to help us out. Let's get some hands up. Claudia has been so awesome today. I wonder if there's any new hands as well. But Claudia, keep yours up because we might need you. Let's see if there's any new hands out there. John,
we got lots. Actually, we had Michelle up, and then the hand went down, but it's back up again. So maybe Michelle, you could turn on your mic and share your thinking with us.
Hi there. Well, I had a hard time getting 5/6 to work out as like compare it to the hundredths.
Interesting.
What did you do? Do you mind describing? Like, I'm curious. Like, what were your strategies?
What's your thinking on that?
Work.
I was kind of all over the place. So I was tempted to do proportions, like 5/6 equals what over 100. That was my first go-to because I do that when I cook. But I tried to. Then I tried to work with. Well, I know that 2/3. Well, let's see. I know that 1/3 is like 33-ish of 100. And then half of that would be like, I guess 0.165 or 165 thousandths. So
half of 1/3 is 0 and 1, like, yeah, that one's a tough one, eh? Like,
yeah, I had to bend my brain on that a bit. Anyway, so that many thousandths.
Ish. I use ish a lot.
Yeah. So then I thought, well, so 2/3 is 4/6. So 2 of the thirds would be 66/100ths. And then I added that 165 thousandths to that. So that's how I tried to get away from my old way of kind of algorithming.
I love it. I love your reasoning. Note, I'm being very intentional about what you actually did, because what you actually did is kind of complex, right? Like you said, like half of that, which I know is that. So basically you multiplied fractions again. A lot of times we do this stuff and we may or may not realize we're doing that. And then you said, okay, well, if I double 1/3, that's 2/3. That's gonna give me double this quantity. And then you added those two things together, and that got you somewhere near that like 0.8.
I think it was 835 if I added right.
And don't forget the ish.
Ish, yeah, I like ish.
Okay, we're gonna throw the ish. Super cool, super cool. I'm wondering, thank you so much for sharing, by the way. Is there anyone else? Feel free to either raise your hand or leave your hand up if you're willing to share your thinking. This was great thinking, by the way. My one wonder, though, as the educator in the room, you're going to have students that do this and you're like, fantastic. Like, you want to encourage this thinking, keep it going. But what about for those other students that are like, I don't know what they just did there? Because like I could, and what I did for many years was like, that's the only way I knew how to do it. So that's what I would do. I'm wondering, go ahead there, John. Is there any other hands up with someone willing to share?
An early hand raiser was Joanne. So Joanne, did you want to turn your mic on?
Hi.
Hi.
Hello. Hello.
Hello.
We can hear you.
Yep, like that commercial. Hey, can you hear me now?
Yeah. Okay.
So what did I do? I started, I had the 5/6, and I knew I wanted to make it out of like into hundredths. because the other numbers seem to be hundreds. So 6, there's no sort of easy way to make 6 into 100 because it's, you know, it's not, you're gonna have a decimal. You're gonna have to multiply by a decimal to get there. I could see that. So I thought, let's do this. I'll multiply numerator and denominator both by 100. So I had 500 600ths, and then I divided them both by 6.
Super cool. So you ended up with 500 600ths.
Yeah.
And then you were like, huh, this is 6 times bigger or greater than what I want it to be. So you're like, if I scale that down by sixthing or dividing by 6, whatever logic you want to think about, you ended up with, I believe, what would that be?
Something like decimal 833. Well, it was exactly, not ish. It was repeating thirds.
Now,
there.
would it be fair to say if you scaled your 600 down by dividing by 6 or 1/6thing, that actually your result for doing the same to 500 would be more like 83 and repeated, right?
Well,
83.
exactly. Sorry. Yeah.
Yeah, no, that's totally cool. Something that I'm happy you brought to our attention is notice the decimal in the fraction. And I think as educators, we worry sometimes about like notation. And early in the journey, we really want to just let students' thinking take them where they're going. Like, don't worry too much about like convention. Don't worry like, oh, like even like decimals and fractions, or, you know, can you have a fraction in a denominator? I'm going to say, go for it, rock and roll. Like if that's where their thinking brought them, we can worry about making it pretty later and helping them get some of those, you know, those conventions down. Super cool. We had so many really cool ways to think about this. But one thing that I do want to really share before, I don't want to run out of time tonight, is I want you to think about this for a second, in that everybody would agree it's like really hard to make like this into 100 pieces. But one thing that I would argue is, like this morning, for example, one of the best guesses, a student said, I think 1 8/10 is going to be closest to this number. And we asked them to prove it. And how this student proved it, they said, well, we know that the one whole is down here, much like you folks had done. So that's fine. And then this student said, you know, I'm going to partition because this is really the same as 1 8/10. All right. We had been using that language. And the student said, well, I'm going to partition this into tenths, much like we did earlier. They said, I'm going to half it, and then I'm going to fifth the halves. So I'm going to do essentially, I'm going to fifth my halves. So I'm going to go, there's 1, 2, 3, 1, 2, 3, 4, 5. I'm going to try to make these prettier and more organized. One benefit of having a digital pen here. I'm going to copy these over to here. Makes my partitioning a little bit easier. It looks like one might be off a bit, but that's okay. It's not perfect. And the student said, now fill in 8 of those. So I went, okay, 3, 4, 5, 6, 7, 8. And then we laid them out next to each other. And by golly, when we did that, they were pretty satisfied, except for one student. One student said, you know, it's not quite right. And we agreed. We said, you know, when we zoom in there, you can see it's not exact, but holy smokes, that's awfully close. And one student said, I think, the student then said, you know what, I think it's not 1 8/10. They said, I think it's more like 1 85/100, or 1 85/100, just like this. So we had a great chat about how the denominators in our base 10 system are limited to tens, hundreds, thousands. And then came the hard part of like trying to actually partition this. I said, okay, well, what would you do to really get these down to hundreds now? And one of the students raised their hand and said, well, I wouldn't partition the whole thing. I'm wondering in the chat, does anyone want to predict what the student said? Instead of partitioning the entire thing, this entire thing into 100 parts, what do you think this particular student suggested that we do to become more precise? Super good, good prediction there. And Michelle says, partition the 2 empty cells, close but not quite. Ezra said, just do half, close but not quite. That's a great strategy. That'll save you half the time, right? That's going to save you half the time. 2 cells would save you like 1/5 of the time, or I should say 4/5 of the time. But you're very close. Denise says partition just 1 empty cell. And that's exactly what that student said we should do. So what we did is we copied this, we brought it into a new page. We said, you know what? Let's go to a new page. And you know what? We're going to make this thing as big as we possibly can so that this is easy to partition. And the student said, make it nice and big. And they said, you know what? From here, let's go ahead and let's partition just this cell. Don't worry about the other cells. So they went, you know what? Partition it. There we go, in half. Now I got to do fifths. 1, 2. You get the idea? And actually, sorry, I think I'm partitioning the wrong cell. I think they wanted this cell partitioned. So I'd do the same thing there. Bang. 1, 2, 3. I'm not going to be as specific as we were with the kids, but you get the idea here. And then we went and moved these around, made them nice and even. And then students came up and they said, you know what? It looks like if we made this one nice and straight from here all the way across, they said, wow, it looks like you could probably fill up 3 of those hundredths right there, because we partitioned a 10th into tenths. And now each of these little guys is 100th. And by golly, we ended up with a pretty accurate comparison. So that student basically went and said, you know what, let's go ahead and let's partition that thing and line it up. And they came out with about 1 83/100ths. And we had one student who said, it's not quite there. We said, okay, let's partition it into thousandths. And then everyone was like, no, boo, I don't want to do that. And I'm like, don't worry, we're not going to do that. To me, I'm like, if they can see tenths and hundredths, I'm not as concerned about thousandths and 10,000ths and all of those. I'll let the calculator worry about that stuff. But here, I want to make sure students understand that when we're dealing with a decimal, we're really dealing with a very limited number of fractions.
Kyle, question from Denise here. Did you, when you did this today, with what grade did you do this with?
It was a grade 7 group,
and
who were just getting into coming back to decimals. But I would do this with a younger group as well.
No, I'm wondering, like, what was the time frame on that lesson you did with them?
This lesson that we did, so of course we didn't do, we didn't spend time explaining the different teacher moves and things.
Right.
We had 1 hour to work today, 60 minutes. We got all the way here, consolidated, and then this is what I sent them away with. I sent them away with a consolidation prompt to bring back to their teacher by tomorrow. It's a virtual class, so they're going to submit this digitally. And basically we just gave them 2 people to work with. Of course, you could modify depending on, do you want them to do it in decimals as well, or percentages? You can see kind of a natural progression here is to introduce this idea of a percentage as being hundredths, and that, oh my gosh, that's going to be really, really awesome. I just want to share with everybody as well, like day 2, we have some purposeful practice in this unit, but then day 3, we bring back the same context, except this time we give every racer 3 opportunities, and how they win the race is their total distance. So now we've got them representing fractions. So like we get them seeing Molly on her first and her second round and on her third round. And then the question kids are left with is, how far did she go? And they're going to have to use representations and essentially kind of work with fractions to go like, how the heck am I going to add these things together? Holy smokes. They can do it concretely, visually, all kinds of different stuff. And then at the end, we say, you know what? Not only are you going to do it for Molly, but we're going to give you an opportunity to do it for these ones as well. And you can see that students are going to do the representations themselves, and then we would consolidate from there. So this unit goes on and it goes on and it goes on. And then we even give them an opportunity to play with percentages on day 5, where they look at another race with another set from the junior divisional champs, except this time the silly sign got in the way. And unfortunately, we can't see who did what, but we can say that the referee told us that these were the total distances. So you can see how we play on this context. So we're not going to spend nearly as much time noticing and wondering on day 2 or 3 or 4 or 5. We're going to build on that context, and we're going to still keep it engaging enough where they're going to continue moving further and further down this pathway, all the way to a 6th unit, or a 6th day, I should say.
I'm glad you said that, because I think a lot of people ask that question, is that, do we do a notice and wonder every single day, or do we do estimations every single day? And you could, but I think, remember, we were just chatting with someone about this idea, remind me of the name. I think it was Liesel.
Yes,
I can't remember the last name, but she had the
Liesel.
brain. She had written some books on brain research and curiosity, and saying, like, you know, the only things are curious because they're novel, you know, they're like new, and you're like, you're going into this kind of your brain is going into some curiosity mode, and it wants to know more. And so I think, you know, when she knew all about, you know, the noticing and wondering routine, and she's like, if you're doing that every single day, kids are going to be like, okay, I'm going to notice and wonder again. You know, it's like, it's going to lose its effect. So it's like, not every single day we're doing a notice and wonder. And I'm glad you brought that up with this 5-day unit, to say, like, we did it at the beginning to kind of get us into the context, and then we can ride that context throughout.
Totally. And, you know, for everyone in the chat, like, some people are liking the progression, and, you know, it is, again, we don't want you to get tricked into thinking that the reason this unit's going to work well for you. Like, I spoke with the teacher today when I was working in her class, and I asked her after, I said, so how do you think the lesson went? You know, it's your students. I don't know how they behave on a daily basis. And she said, wow, like, the lesson went really well. And I said, okay, well, what were some things that you thought made a difference? Like, what were some things that you thought mattered? And she said, well, you know, the context was really good. And the one thing, I stopped her right there and just said, but just be careful, because I need to spend the majority of my time thinking about the context and how I'm going to deliver the lesson, and less on making it look pretty. John and I like making these things look pretty because it's kind of like something we do. But in reality, you should be focusing on, like, how am I going to ask them questions? Because the second thing she said was, the one thing that I thought was really good was I got to hear students thinking. And that, to me, that's what we're after, is like, how do you get them thinking? We call it sense making, but really at the end of the day, like, we've got to fuel that sense making, and we can do that in many different ways. The visuals, we provide them for people because we want to give you, you know, some fun opportunities to kind of up that ante a little bit, but it's not going to look like that every single day. Right. So this is going up to our website this week. And you folks obviously are more than welcome to have at her and give it a shot with some students.
Right. And this is another good question. Lindsay is asking about assessment, and like, how do you assess this kind of thing? And I think we got to remember, like, the difference between assessment and evaluation too, because sometimes it's like, well, how do I like give them a mark on this, or what do I do? And I think, I'm not sure if that's what you mean here, Lindsay, about that, but for something that we've been, you know, thinking about for a long time, is that we're always assessing from the moment the kids walk in the door to the moment, like, she's like, just checking for thinking. Like, I think we are doing that constantly. And having your students go through an activity like this, you're assessing and getting their thinking. When you're, like you said, Kyle, that the teacher said they loved hearing the thinking, right? If you can put your students in a position where you hear the thinking, that's your assessment. Like, you're listening to where they're thinking, you're going to be ready to engage them, how to push them forward. Like, that's assessment, is getting information so that you can drive learning forward. That's all we're viewing assessment as. So we're assessing all the time because we want to keep pushing that learning forward. So how do you record all that? Sometimes you don't record it. Sometimes you listen and engage and push learning forward. Sometimes you can record that by taking pictures. Sometimes you can record that by have students take pictures and then comment on their work after. You can, have them like this consolidation prompt. You can have something similar at the end that says, hey, this is where I was thinking. This is where I'm thinking now. Like you can have those come back and then you can see that. So the idea about assessment is just like, we want to push the learning forward. What information do we get? But I think the lesson itself, the way it's structured this way, to following, say, the 3-part framework, you get so much more when the students are showing the work and doing the thinking, and you just get to sit back and listen and engage to push that thinking forward.
Yeah, that's a great point. And I pulled back up this consolidation prompt because in all of our units that we design, we always like to put a prompt or two at the end. And if it is something that you do want to bring in for yourself to check thinking. So if, let's say, like John's saying, you're observing, you're having conversations with students, you're looking at their product as they're working. But let's say you want to make sure who heard what, or you want to know who heard what, because the reality is sometimes in class as they're collaborating, students are working together, and it sometimes skews your thinking to think like, wow, we're good. Like we're good to go. When you give a consolidation prompt, let them do it independently. And maybe it's like, maybe they take it home and they hand it in tomorrow, or maybe they hand it out as a ticket out the door. But just to quickly look at that and kind of go like, okay, who's with me here? Like who got the point of the consolidation that we did today? And oftentimes, more often than not, it's actually kind of disheartening sometimes when you look at these and you look and you go, oh my gosh, I thought they knew more than they really did. So these are great for that. There's another question too. Seagram in the chat is saying, like, if you implemented this method, how many specific expectations can you get through in a 5-day lesson? Now, I'm not going to, I want to address it, but I don't want you to feel bad about it. But the language of getting through expectations is something that we try to leverage. We had a colleague, Alex Overwick from Ottawa, great guy, fantastic math educator. He talks about uncovering thinking, uncovering expectations. And here, just to give you a sense, we're not going to like try to get through it and be done with them. We want to emerge them. So some of the things that come up in this particular unit, and I hope you saw some of them, I'm not going to be super specific to which ones they are, but we saw representing fractions for comparing, for equivalence. We also saw adding fractions when I shared that you're going to do 3 different heats and you're going to add those together. Try to emerge this idea of like how a common denominator is very helpful. We talked about multiplying fractions. I wouldn't call that like, something we explicitly addressed, but we talked about how that idea comes out. Yeah, exactly. And we're merging these ideas. And we also talked about conversion between fractions, decimals, percents. And then there's also a day in this unit where they give different metric units. So centimeters, meters, and so on and so forth. So I hope you see there's a lot there, but it's up to you on what you're going to explicitly bring to the forefront. And if you don't realize they're there, then they will just kind of go under the, under the radar.
And you've pointed that out here, that they're there. And I think sometimes we think that our lessons have to be very linear, right? It's like the textbook will lay it out, or your resource guide or your scope and sequence plan is going to lay that out very linear. Like if you're going to do your fractions unit, you got to do equivalent fractions, then you got to add fractions, and then you got to multiply fractions, and then you got to, subtracting fractions was in there too. Like it's all laid out. However, what Kyle has shown is this lesson kind of uncovered all of those ideas kind of at once. And we're not saying we've covered all of those, or we are proficient with all of those skills at this time, but they're out into the open, that you've had discussions about them. So then when you bring out back, like he said, you're going to specifically target maybe 1 or 2 skills in there, but then later on, you can revisit this and bring up say, I want to now practice more adding fractions. I want to practice now subtracting fractions. Well, you try not to get stuck in that our course has to be very linear. We can bring out and emerge through the activities themselves. And then you can focus on what you want to practice with your students. And bring it back to assessment from like Lindsay's question. It's when you see where, like if you can give you did another activity and gave another prompt, and maybe it was about subtracting fractions in there, and then you can see where is it? Like Kyle said, is everybody with me? It's like, now you can see, is everybody with us? Okay, no. All right, well, we got to revisit and subtract fractions on another day. Like, you constantly are reassessing, going, where are we on our learning goals, through the use of activities and bringing out different concepts. So it doesn't have to be linear in that order.
Yeah, fantastic. And actually, one other thing I wanted to share as well, there's some others that I forgot, but the associative and commutative properties, which are a big deal now in the elementary curriculum in Ontario. Like, I don't know if you can see it here, but when I take 2/3, if you look and focus on this worm right here, if I take 2/3 and 1/3 and I commute this 1/3, I disassociate it with this fractional amount, and I reassociate it over here to make a whole. That's addressing some of those properties that are now explicit in our Ontario curriculum. So you can see it there. Bang, we just made a whole out of two separate fractions by decomposing, recomposing. So much here. I love the questions. You know what that tells us there, John, is like, when we get these questions, we have people truly thinking about how this works in their own context.
Exactly.
I love it. And I really appreciate that you all take the time out of your own day to hang out with us. As we mentioned, John and I, we're running out of time here. So as I mentioned, this is going to be up on the website in the next couple of days. So how you can find them is by heading to our website and going to, let's see, is it right there? There it is. You can go there and you can access these tasks. Uh-oh, it's kind of going on its own again, John.
Uh-oh,
look at that.
What'd you do?
Yeah, totally. But that website right there, and John will put it into the chat.
Yep.
Check out what's going on there and grab a unit and have a look. Obviously, don't just blindly follow it, but have a look and look at the teacher guide and make sure that you have clear intention with what it is that you want to emerge. And it does take practice. We say that teaching math is like part science, but very much so an art form as well. And it's something
lumpy.
that I think it continues to evolve over time. So with that, again, check those tasks out. We're going to be hanging out with you again next week. And here it is now the
Michelle,
correct slide.
Are we next week?
It's not next week.
I think next
It's
week's
after
like
the
there's a break for the holidays. Right, Michelle?
Yes, indeed. I know that Kyle is getting very excited, but we're going to break for the holidays.
Right.
I think the next session is on January 14, but I'll mention it in a second. But yeah.
All right.
Fantastic.
Thank you, Michelle. One last thing we want to do, as always, we had 3 things that we were hoping you got from this session, and one of them was trying to strengthen or reemerge your understanding of mathematics. Give us a yes if we did that in the chat. Like, did we help think about like fractions here? Give us a yes in there. One of the other things
they're starting to come. Good.
Here they come. I was worried that we didn't show any math here.
We're going to waterfall it.
Right. We talked about fractions, decimals, and percents conceptually, right? We wanted to make that clear because we all know that we can teach the algorithms of how to add, subtract, multiply fractions, but I think re-encouraging conceptual, visual representation of these ideas. Give us a yes in there. And then the last one, Kyle, or I guess it would.
Yeah, let's keep repairing and strengthening. Yeah. I hope folks feel that relationship is strengthening. Even if you felt pretty strongly about mathematics, hopefully you're feeling even better, even more building that productive disposition. Those are 3 big things for us. Friends, we've had such a blast. We're going to turn it over to Michelle.
Yep.
In the chat, let us know. Give us something that you took away from today. And remember, there is a Academy 30 days for you to explore if you want to go check it out. But those tasks are open for you to use at your will.
Back to you, Michelle.
Okay, great. Thanks so much, guys. I mean, I love this session. It's unbelievable. I'm not a math person. I was a photography teacher. I was an art teacher. So really, really far from mathematics. But I really love everything. And I love that we learned about not only about fractions, but we also learned how to make animations in Keynotes, which I think that everybody enjoyed that as well. And these sessions are always really creative. And I remember, because I relate to my time in high school, how mathematics was so scary, because I was pretty good at science and I love science, but math was very dry and quite boring and very scary. I remember the teacher putting equations on the blackboard, and then you would pick someone into the class and you would have to go in front of everybody and resolve that equation, and your brain would kind of freeze under the pressure, because so you couldn't do it. And what I like about you is that it's never about the answer, it's always about the process, it's always about the thinking and how we can work together and try to resolve something. And everybody makes mistakes and we learn through our mistakes. So that I really love that. And I guess I had to grow old to meet you guys and see that math can actually be a lot of fun. And I guess it's never too late to go back to school. So just to conclude the session, I just want to remind everybody you're going to get a follow-up email tomorrow, and there is a little questionnaire in the follow-up email. We like you to please answer it for us to improve our webinars. And you will also receive the recording of the session as well as all the resources that have been shared today by Kyle and by John. So as we mentioned, we are not going to be back next week. The next webinar is on January 14. We have 3 in January on the 14th, 21st, and 28th, and then we're going to have 3 more in February. So we still have lots of really exciting webinars coming up. And so mark the next one, January 14, ratio and rates. And yeah, so I wish you all very good year-end holidays and a happy new year. And I will see you all in January, mid-January, for the next session.
Awesome stuff. Thanks so much, Michel. Thanks
everyone. So much. And I want to also say thank you to who were the 3 courageous, who was there? Michelle, Joanne, and Claudia. I remember I said they were very brave to volunteer and raise their hand.
You're
and
right.
So I just want to thank them and thank all of you as well. Thanks so much.
Thank you, Michel. Thank you everybody for joining us, and we'll see you in the new year.
In the new year. Take care, everybody.
Happy New Year.
Enjoy the holidays.
Bye, everyone.
Bye.